Hello and welcome back to my channel. In this tutorial, I'm going to talk about univariate interpolation in Python. This tutorial is about how to use SciPy univariate interpolation functions. And this is the first part of the tutorial, and we'll cover the second part as well. Interpolation is a technique used to estimate unknown data points within an unknown range, aiming to create a smoother curve. Univariate interpolation specifically focuses on fitting a curve to a set of two-dimensional data points sampled from a single variable function. This process enhances the continuity of the curve within the given range. SciPy API provides several functions to implement the interpolation method for a given data. In this tutorial, you will briefly learn how to apply univariate interpolation for a given data by using the several functions of the SciPy library. This tutorial covers preparing test data, one-dimensional interpolation with interp1d, CubicSpline method, PchipInterpolator, that is Piecewise cubic Hermite interpolating polynomial, and Akima one-dimensional interpolator in source code listing. We'll start by loading the required libraries. Here we use SciPy, Matplotlib, and NumPy. First, we'll create a simple x and y data for this tutorial. We can visualize it on a graph and apply a linear interpolation. Linear interpolation is a graph is simply connecting data points linearly. This is a sample x and y data, so we visualize it. The first method is one-dimensional interpolation with interp1d. An interp1d class finds the value of a new points of the one-dimensional function within a given method, such as linear, nearest, cubic, and etc. The below listing shows implementation of interp1d method. First, we'll fit model on x and y data, then provide new x data to find out new estimated y values. Here we will define the new x data, and we use interp1d with x and y and fit it new x data and visualize it in a plot. CubicSpline uses a piecewise cubic polynomial that is twice continuously differentiable to interpolate data. The implementation of CubicSpline method is similar to above scripting. Here is how to use CubicSpline. So we provide x and y data and fit the new x data and visualize it in a plot. Piecewise cubic Hermite interpolating polynomial 1D monotonic cubic interpolation employs monotonic cubic splines to determine the value of new points. The implementation of PchipInterpolator method is also similar to above scripting. Here is how to use it. Akima 1D interpolator fits piecewise cubic polynomials. Akima's interpolation method employs a continuously differentiable subspline constructed from piecewise cubic polynomials. The implementation of Akima 1D interpolator method is shown below. Finally, we'll put all together in one graph and compare each method's performance within a given data. The following listing shows how to plot all in one graph. First, we'll fit all interpolation methods, and we create a dictionary, and we visualize it in a 2x2 subplots. Here we iterate, and we'll use all the functions here and visualize it in a plot. Here is the result. The first one is in one-dimensional interp1d and CubicSpline and piecewise cubic Hermite and Akima one-dimensional interpolator. So there is a slightly difference here. So you can use the appropriate method for your according to your fitting criteria. Here is a source code. I'll put the link in description. So you can just copy all of the source codes, and you can use them in your analysis. In the second part of this tutorial, we'll explore another two univariate interpolation methods that are the barycentric interpolator and KroghInterpolator methods. Here we prepare the test data, x and y data here, and visualize it in a plot. Here is the target data for us. Barycentric interpolator constructs a polynomial based on a given set of points, allowing for a polynomial evaluation, efficient interpolation of y values, and updating y values with the addition of new x values. Below code shows the usage of the barycentric interpolator method. First, the model is fitted with x and y data, and then new x data is provided to obtain corresponding estimated y values. Here, how to use barycentric interpolator in the class here. The next method is KroghInterpolator method. This method evaluates both the polynomial and its derivatives. Its implementation is similar to the previous listing. The model is fitted with x and y data, and new x data is provided to obtain new estimated y values. Now we can visualize both methods on graph and compare each method performance with a given data. Below code shows how to plot all in one graph. Here is first we generate a new x data, then we will fit each method on x and y data, and we fit new x data here and visualize them in a graph. Here is the result. The first one is barycentric interpolator, and the second one is KroghInterpolator methods. Result looks very similar, so you can choose the appropriate one for your analysis. That's it for this tutorial. In this tutorial, we briefly learned how to use univariate interpolation methods with SciPy functions. Here is the source code. I'll put the link to source code in description. If you like this video, please subscribe my channel, hit like button. Thank you for watching, and see you next time.